Welcome to day 16 of the macOS and iOS Security Internals Advent Calendar. Today we will be looking into KDK and how we can use its lldbmacros to have nicer visualization of the kernel inside lldb. So first of all, the KDK or kernel debugging kit comes from Apple. It is available as download for registered developers, and it contains the symbols for the main kernel. It contains alternative debugging kernels. It also contains symbols for various closed source kernel extension, and for us most interesting is it contains the macros for lldb, KDP debugging, but also for just having the macros in case of remote kernel panic dump. So you can download them from Apple at developerapple.com/download/all, but only if you are a registered developer, you have a developer account, and then you can get them. But yeah, then they are free download basically when you have the subscription. And yeah, you would have to download the right version for the right build number, and the build number you would see from your victim basically. So ever since Yosemite, these kernel debugging kits come as package files that you can install on the system, and then all the KDKs that you install will be in /library/developer/KDKs with then for each version a different directory. There used to be just like a DMG file that you can mount, but this is a much nicer way to do it. So when you open the kernel debugging kit, you will find a bunch of binaries that have dwarf debugging symbols, so they are very nicely debugged symbols. And you can open them with tools like, for example, here IDA, as you see. And here you can see in IDA we have a lot of symbols here. You can see 25,000 functions. All of them have usually names because they come from the symbols. You can see the parameters are also available for each function. IDA can make a lot of sense what is from the names and everything. Variables and kernel memory also have names, so it's very nice for looking at the kernel even in binary format. So, and now back to our panic dump. We can now, when we connect to the panic dump, we will get this kind of output here, and as you can see this, you basically have a warning that it knows the kernel, but it also offers you to import the scripts from the kernel. It also finds the kernel symbols for some of the drivers, and it also finds the list of all the drivers that it cannot reveal. And then you can also look into the backtrace, symbolized, and all this kind of stuff. So the important thing is you would have to run this script to get access to the macros. So yeah, that's what I'm saying. When you start lldb, it will warn you that there's this script, and you just copy this over, run it, and then it should give you access to the scripts. You can then try to run kgm help to see a list of all the available comments. I will give you a real world view on this in a moment, but for now, one thing you need to keep in mind is that depending on what version you're dealing with, these lldb macros used to only work with Python 2. If you're in this version, you would have to ensure that your system uses Python 2 for lldb. Recently, on the recent kernels, you don't need this anymore. It's now Python 3 compatible. But then you need to install additional stuff into your Python installation. For example, here pip install macOS. This is something you needed to do on Python 2 with brew. If you have Python 3, you have to do it also in the Python 3 for normally, because it's not installed by default. And yeah, as I said, we will look into this in more detail in a moment. And here is an example when you run kgm help. This is some of the hundreds of comments that are added to the system. Yeah, it's very nice, and you will see some of the comment in a moment. Yes, let's just jump into the real life demo and this slide deck and just see how it works in reality. So in order to install the right KDK for our target, we should first have a look into what our target actually is. So we can say sysctl kern.version. We can say kern.os version. And then we have the build number, which is 21G72. And we can also use this one here and see we are on macOS 12.5. So with this, knowing this, we can just find the right KDKs, and I have already downloaded a bunch of KDKs. So let's just start the installation process of the KDK. I have the KDK here. We just run it. And I have the KDK installer here. Let's run this. Continue, agree, install. Now I need to install it via the root password. That hopefully does all the work now. Okay, this should have installed it. Now let's try attaching to our LDB core. So this time we got a lot of stuff here. So let's start here in the beginning. It detects the kernel and says we have the possibility to load scripts inside the kernel. It also detects some other IO graphics that also has debugging information. It finds a bunch of kernel extensions in memory, and it warns us that the kernel was compiled with optimization, so that single stepping might behave strangely. I think that's mostly for source stuff. Yeah, it has loaded this now, and yeah, what happens when we try to run this here? So it tells us it wants us to first install the macOS. This is always dependent on how your Python installation is. So let's do this, what it recommends. Let's run this. So let's see. Oh, I think it needs another stuff. because I'm doing it the first time on this system. This time it worked. So now we have the LLDB macros loaded, so now we can use kgm help. And as you can see, we have here a ton of the possible comments that are supported with kgm help. Make this a little bit bigger. So yeah, so kgm help is very powerful because it gives us information and deep insight into the kernel. When you look at it, you can see, let's see, there's a very interesting, there's some show proc tree comment, if I remember it correctly. Yeah, show proc tree. Let's run this. And when you run show proc tree, you can basically see all the processes that were running at this time of the crash. You see the process ID, the parent, you see the name, you see the proc structure pointer inside the kernel. And when you scroll down, you can even see the dtrace that caused the kernel panic, which was called via sudo in a set shell via our login from the terminal app. And yeah, this is basically one of the many comments that exists. And you can then see stuff like, you take for example, let's say the dtrace, for example. You can then look into the dtrace stuff here. This is the dtrace, the memory of the dtrace proc structure, and that's basically the dump of the proc structure here. And like I said, there's many of these comments here, and it's quite nice to play around just with the comments. And if you want to look in how the comments are implemented, you can just open the for example the XGNU kernel source code, go to the tools directly to lldbmacros and see how all of this works. So, but one thing that is also important is that you can go into Python scripting. And inside Python scripting, of course, you have all the kgm help, the lldbmacro stuff also available. So you have access to stuff like print xgnu kern globals dot, and then for example real host, which is the kernel variable, and of course, this is Python 3, so we have to use Python 3 syntax. So here you can now see we have here the real host printed out. You can see the arguments inside, or the fields inside the real host structure, and you can really drill down. Of course, there's also the all proc variable. So you can go through the list of all running processes, and you can, so for example, use the LH first, but you have to dereference it. So you dereference the first one here, and then you can see all the proc structure content for the topmost process in the all proc. So you see the user ID and everything. You can see down here that this was, where was it? Core symbolication D. So that's the information here that you will find. And yeah, you can walk the list of for the next process. So there's the P list. So you can go P list, and you go to the LE next. you have to dereference it, and you will get this here, which is now the dtrace process, and so on and so on. You can walk everything, and you have access to all the variables that are basically available as symbols in the KDK. Yes, and this is a toy you can really play around with, and I leave you with that until next time.